In this video, we're going to talk about writing equations of lines. In your book, this is chapter 5. First example says, write the equation of the line whose slope is 4 and y-intercept is 7. We already know slope-intercept form of equations gives us our slope m and our y-intercept b. So since I'm given these things in the problem, my slope is 4, my y-intercept is 7, the best form of equation to use is slope-intercept for this one. So I'm simply replacing m with 4 and 7 with b. So I get y equals 4x plus 7. It's not asking me to convert to any other form or doing anything special with that one, so that is my answer. Second one says, write an equation of the line whose slope is 2 and goes through the point -2, 3, and I'm going to write it in slope-intercept form, but I'm not going to start with slope-intercept form. I don't have my y-intercept, I just have another point on my line, but I do have my slope. So let's figure out how those two relate. We know our slope is equal to change in y over change in x. Well, I have one y coordinate and one x coordinate. I want to keep my other one unknown because I don't know it. So that means I'm going to have y minus my y coordinate here. We'll call this y sub 1. And x minus x sub 1, which would be my x coordinate that I'm given. This is a proportion. I can solve this proportion by doing my cross products. When I do my cross products, I get, if I put this over 1, I get y minus y sub 1 is equal to m times, and remember this has to go in parentheses, x minus x sub 1. So I can fill in the information in here that I know. I can plug in 2 for m, and I can plug in my y coordinate I know is 3, so that means I'm going to have y minus 3 is equal to 2 times x minus my x coordinate. My x coordinate's -2, so if I'm subtracting that x coordinate, really that means I'm adding. Not quite slope-intercept form yet, but almost there. All I have left to do is to distribute the 2, so I get y minus 3 is equal to 2x plus 4, and then add my 3 to both sides. And I get y equals 2x plus 7. That's the final answer for my equation there. We have different forms of linear equations that you might be asked to use or work with or write equations in the form of. The first one is standard form. Standard form is ax plus by equals c. You've worked with these already. Think back to the problems where we had we were talking about selling seats in a theater or something like that. Those were our standard form equations. You'll notice that x and y, my x and y variables are on one side of my equation, and my constant, my c, is on the other side. Keep in mind, a and b and c are integers, and a and b cannot both be 0. If both of them are 0, I don't have an equation here because my variables would be multiplied with those zeros and I get 0. We already know slope-intercept form is our y equals mx plus b. M is our slope, b is our y-intercept, and then today we learned our point slope form. Point slope form says that if m equals my y-coordinate subtracted over my x-coordinate subtracted, then the equation of the line is the cross products of this proportion. Right there, giving me my point slope form, which is what we just did in the previous example. Example number 3 says, write the equation of the line through point 26 with a slope of 1/2 in slope-intercept form. Again, slope-intercept form is not my best form to start with because I don't have my y-intercept. So I'm going to use my point slope form here. Remember, my point slope form says that my slope, which I know is 1/2, is equal to my change in y. I have one of my y coordinates, so that means I'm going to have y minus 6 on the top. Over my change in x, I have one of my x coordinates, so that means I'm going to have x minus 2. When I do my cross products, since with this being a fraction, I want to eventually get y by itself, so I'm really going to see this as 1/2 over 1. So that when I do my cross products, I'm multiplying 1 times y minus 6. And then my other cross product to be 1/2 times x minus 2. Last step is to simplify this up so that we can get y by itself. Distribute the 1/2. And then add 6 to both sides. And there's my answer in slope-intercept form. Next one says write the equation of the line through this point with a slope of 8 in standard form. Again, because I have a point and a slope, kind of makes sense that I use point-slope form. By now we can remember that point-slope form is how we get that form is by doing those cross products. So really I can plug right into that second step and say y plus 5. Remember we had y minus my y coordinate, and my y coordinate here is negative, so that means I'm going to have y plus 5 is equal to my slope, which is 8, times x minus my x coordinate, and my x coordinate is 1/3. To get this in standard form, my x and my y have to be on the same side, my constant's on the other side, so I need to distribute the 8. Remember, we also said that a, b, and c are integers. I don't want to leave any weird fractions in there, so I am going to go ahead and multiply everybody by 3 over 1. Y times 3 over 1 would give me 3y. I have to multiply that 5 by 3 as well, so that's going to give me plus 15. 8 times 3 gives me 24x, and then 8/3 times 3 is going to give me minus 8. Now I can start to simplify this some more. I'm going to subtract my 24x from both sides. So I get negative 24x plus 3y plus 15 is equal to negative 8. Then I'm going to subtract 15 from both sides. So I get negative 24x plus 3y is equal to negative 23. Sometimes you'll see textbooks, if you're looking in the back of a textbook for an answer, you'll see this written as 24x minus 3y is equal to positive 23. Really, these are equivalent answers. It's just taking this answer, the book is taking this answer and multiplying through with a negative, because we talked about one of the most common mistakes is dropping negatives. So if I have a negative in the front of my equation, the potential for dropping that is pretty good. So a lot of times books will multiply negative 1 through just so there's no confusion. Take a look at this one. Write an equation of the line through point 46 with a slope of 0. I'm still going to use my point slope form because I have a point and my slope, hence point slope. So that means I have y minus 6 is equal to, my slope is 0, times x minus 4. Wait a minute. 0 times anything is 0. So 0 times x minus 4 is going to give me 0. And if I solve for y, that means I'm going to add 6 to both sides. So I get the equation y equals 6. Does that make sense? Well, if I have a slope of 0, I am talking about the horizontal line right there. That would be my slope of 0, and that is the equation of my line. Number 6, a little bit different again. We have a point, 7, negative 4, but we have an undefined slope. Remember, think back to what an undefined slope meant. Undefined meant I had 0 when I did my change in x. So really, I'm looking at a slope, say, 1 over 0. So let's use that. That means I'm going to have y plus 4 is equal to over x minus 7 is equal to 1 over 0. So when I do those cross products looking at my slope, I'm going to get y plus 4 times 0, well that's 0, and x minus 7 times 1, well that's x minus 7. So I add 7 to both sides, and I get x equals 7. That also makes sense because remember, undefined slopes are my vertical lines. So if I were to graph this, I would have a vertical line right there at 7. It says every single x-coordinate has to have an x-coordinate of 7. Write the equation of the line that passes through -2, -5, and 7, -6 in slope-intercept form. So this was a little bit more complicated because I didn't give you the y-intercept, and I also didn't give you the slope. So you have kind of two things to do. First thing I'm going to do is find my slope, because that's the easiest. I know my slope is change in y over change in x. So that means I'm doing -6 plus 5 over 7 plus 2. That's going to give me -1 over 9. Now I have my slope, I'm halfway there. If I'm going to use my slope-intercept form, then I'm halfway there. I have my slope, but I don't have my y-intercept in the problem, and I don't have, neither one of these points is my y-intercept. Remember, to be a y-intercept, you have to have an x-coordinate of 0. So I'm thinking I probably want to use point slope here because I have a point. In fact, I have 2, and I have my slope. So here's where I get to make a choice. I can choose which point I want to use. Doesn't really matter. Somebody might choose this point to use with the slope. Somebody else might choose this point to use with the slope. We're going to get the same answer in the end. So I'm going to choose this one. I don't know why, I just like it better. So when I plug it into my point slope form, I'm going to get y plus 5 is equal to -1/9 times x plus 2. I want my final answer in slope-intercept form, so the only thing I have to do now is solve for y. So I'm going to distribute -1/9 and then I'm going to subtract 5 from both sides. Remember, when I'm subtracting with this negative number, you can change this into 45/9 because 45/9 is 5. So -2/9 minus 45/9 gives me -47/9, and there's my equation in slope-intercept form.